All right, let's resume class. Good thing is we don't have defense, but we have finite. We just have one final result. We got text average. Okay. All right. Hopefully we can wrap up the evolution today. Okay. First off, let's see this. Okay, what is ozone? Okay, what is ozone? I know. Everyone said, okay. Let me see my notes. Okay, we just mentioned that. Ozone is also a major component. Okay, ozone is also a major component of photochemical smoke. Okay, so actually ozone is ozone form when NOx from NOx plus VOCs and produce ozone. So this means ozone is not primary pollutant, right? So ozone is something called secondary pollutant. If you still remember, okay, the secondary pollutant. So ozone is a secondary pollutant. Okay, for example, like SOx or NOx. SOx or NOx, they are primary pollutant. Okay, because they become SOx and NOx directly from the fossil fuel burning. But ozone form when NOx react with mechanical organic compound, VOCs. So ozone is a secondary pollutant. Okay, and the clear skies, so under sunlight and even high temperatures. So sunlight and heat will stimulate 刺激 ozone formations. Therefore, the peak level of ozone usually occurs in summer. Okay, so from this website, I just sent you a website, right? Student, I just sent you a website to the online group. You might also see the ozone label. Okay? In this website, student, take a look. You can check AQI and check particulate matters, right? And you might also check the ozone label, and also NOx. Okay? Do you know where is this area? Taipei. Yeah, Taipei. So this is Taipei. This is Taipei. Okay. ozone is also very powerful oxidant. Okay, so our tissue or our immune system is also very sensitive to ozone. Okay, so the power oxidant means our biological tissue easily react with ozone. So let's see this. The concentration of 0.012 ppm can irritate 刺激. Okay. Very similar to stimulants, okay, but this make you painful, irritates your respiratory tract and impair lung functions. Okay, so it's gonna cause you, for example, like coughing, like shortness of breath, even chest pain, And exercise will increase this effect. So if you have very heavy exercise, okay, what you can endure will be lower. Okay, if you do not exercise, you can endure 0.0 But if you have a very heavy exercise, okay, it can appear even at very low ppm, like 0.08. Understand? And I say that, okay, it's also related to our immune system, right? So you're gonna lower, you're gonna weaken, okay? The ozone exposure, you're gonna weaken our body defense. Okay? So on the market, there are some ozone producing machine used for disinfection. But if you turn the ozone producing machine on, you should leave. Okay, you should leave the room. Okay, you cannot stay in the room while the machine is producing ozone. Understand? Okay, so after like 1 or 2 hours, you come back and turn off the machine and open the window for the disinfection purpose. Okay, and of course respiratory, like edema, right? Okay, and hospital administration, 住院的人就增加。Hospital admission rates around 7 to 10% if the ozone level increase 0.05 ppm. Okay, 0.05 today or tomorrow. Okay, for example, tomorrow, okay, the air quality not good, and the ozone level increase 0.05%. Then the hospital admission will increase 7 to 10%. Understand? Finish? Anyone? Okay, next I would like to talk about the tropospheric, tropospheric photochemical pollutant. Okay, if you still remember, our atmospheric level, student, take a look. The lowest, I mentioned this last night, right? The lowest atmospheric level is called troposphere. Okay, it's called troposphere. So short distance dimensions, the short distance airplane will fly in this level. And there's lots of turbulence. So you will not feel comfortable for the short distance flight. Okay. And on top of it, it's called stratosphere. Stratosphere. And ozone layers in this table. Okay, ozone layers in this table. Not all the stratosphere is ozone layer, just a part of it is ozone layer. And long distance fly will fly, the airplane will fly in this table. So it's more steady. Okay, it's more steady. Okay, so we're gonna talk about the tropospheric photochemical balloon. So this is the tropospheric level is the lowest. It's the lowest atmosphere. The lowest atmospheric level. Okay, and we know that the photochemical reaction which lead to ozone formations. Okay, from the release of nitric oxide and volatile organic compound, VOC. So I should stand for hydrocarbon. Hydrocarbon is also one of the chemicals. So actually you should use VOC here. Okay, imagine this. Ozone can use to kill oxygen. Ozone 可以拿来杀菌。Ozone can be used to kill ozone can be used to kill bacteria. Right? Think about this. Ozone can use to kill microorganisms or bacteria. Of course, it can use to it will damage your body system. Okay? So keep this in mind. Ozone actually is toxic. Okay? Ozone actually is toxic. Understand? Okay, we mentioned this. Okay, we already mentioned this. Okay, so ozone is a second. It's a secondary. Okay, and worse in summer. Okay, and even worse in city, the urban area. Okay, next slide, I would like to talk about the stratospheric ozone. So this is stratospheric is the second lowest. The second lowest level. Okay, troposphere then stratosphere. Okay, above troposphere. And the ozone layer, the layer here. The ozone layer is formed from 15 to 30 kilograms from atomic oxygen and molecular oxygen. Okay? So, stratosphere is from 12 to 17. Okay, this stratosphere and ozone layer is from 13 to 30. Understand? Ozone layer 只是这个那个平流层的一小部分而已。Just like this. From 12 to 70, this is stratosphere. From 15 to 30, this is the ozone layer. Okay, it's the ozone layer within the stratosphere. Understand? But we say ozone is toxic, but ozone actually is very important. Okay? The ozone is used. The function of ozone. The function of ozone is used to block UV. Okay, it's used to block UV. We have three kinds of UV. UVA, UVB, and UVC. Okay, actually we have three kinds of UV. UVA, UVB, and UVC. Okay, the wavelength of UVC is the shortest, but the energy is the highest. Okay, UVA will just cause you aging. Aging means make you older, make you produce some wrinkle. Okay, it's exposed a lot to UVA. Okay, it will make you aging, make you look older. However, UVB and UVC will cause you skin cancer. Okay, skin cancer. Okay, no racial discrimination here. No racial discrimination, especially Caucasian, the white people. Okay, exposure too much to the sunlight will get skin cancer. Okay, so this is the good thing about the ozone. We say ozone is toxic, but ozone layer is just our. You can think about, you can regard ozone layer as our protective layer to help us to block UV. Understand? To prevent us getting skin cancer. Especially for Caucasian, the white people. Okay? Next. So this is the formation of ozone. Okay, this is formation of ozone. So the oxygen is broken by the HV here, this is sunlight. Okay, this means sunlight. So the ozone, oxygen is broken by the sunlight. Okay, it's broken by sunlight. Become oxygen. Actually, it's oxygen-free radical. And this oxygen-free radical is very unstable. And if this is not very unstable, means this is very reactive. Okay, so it's very reactive. It will react with oxygen to form ozone. So in opposite, ozone can be broken by UV. Okay, become oxygen gas, molecular oxygen, and oxygen-free radical. Okay, the DU stands for the Dobson unit. Okay, this is a unit of measurement of amount of trace gas, for example like ozone. For example like ozone in a vertical columns through the Earth's atmosphere. Okay, so if smaller than if 300, okay, if 450 means normal, there's no hole of the ozone. However, if less or equal than 90 DU, that means the ozone layer is broken into a hole. We call it ozone hole. Ozone hole. Understand? And let me show you. I think I put it one of the photos. Okay, in another PowerPoint slides. But so let me Google it. The funny thing is the ozone hole. Is still during COVID-19. So you can imagine how. So take a look. Before COVID-19, there is a hole. There is an ozone hole. Okay? And during the COVID-19, okay, this one you can see that. Okay. Okay. Taking a photo. Okay. This is taken on April 16, 2020. So it's just a little bit time after COVID-19. So there is still a hole. Okay. There's still a hole. Maybe not this one. Yeah, this is funny. Okay, there's a hole, very big hole, ozone hole. And during COVID-19, the hole is sealed. The hole is sealed like this. The hole is fixed. So you can imagine how much damage we human beings do and did to our mothers. Okay, so this is, I think the environmental engineering is a very good course. All the students should take it. Okay, especially for chemical engineering. Especially for chemical engineering. Okay. There is a Chinese saying. Okay, there's a Chinese saying. 解铃还须系铃人. That means who tied the bell? The one tied the bell, and the one can untie the bell. Okay, those pollutants generate by chemicals, right? So it's our responsibility as a chemical engineer to solve the problem. All right? Okay. So how the ozone layer be broken into a hole? Okay. So this is the Keller. This is the mother, or this is the big guy. It's called chlorofluorocarbon. So chlorofluorocarbon is the guy. Break. Or broke. Okay, broke, and now still breaking our ozone layer. Okay, this is the dye. Okay, I think I cannot skip this. You might learn this in organic chemistry, right? Okay, so actually our ozone destruction or Sometimes we call it depletion. Depletion is consumed. Okay. Ozone depletions by this chlorofluorocarbon. Okay. The chlorofluorocarbon will be broken by UV into this free radical. Okay, and as I mentioned, those free radicals are very unstable, which means they are very reactive. Okay, so they will react with ozone. They will break ozone into oxygen. And this is a chain reaction. This is a chain reaction, means it can continue, repeat. Understand? Okay. So next I would also like to talk a little bit about the greenhouse pollutant. Okay. So it causes the global warming and leading many secondary effects. For example, like changing the sea level. Okay, and also the temperature increase. Okay, climate changes as well. Okay, we all learned this, right? So there are some famous greenhouse gases, for example, like carbon dioxide, methane, and chlorofluorocarbon is also kinds of greenhouse gases, and nitrogen oxide. Okay. Okay. I already mentioned that the chlorofluorocarbon is very good coolant. Okay, chlorofluorocarbon serve as good coolant, the cooling agent. Good cooling agent. In the air conditioner, all the refrigerators. But it's banned. It's forbidden. You cannot use that anymore. In most of, I would say in most of countries, but some countries still use them. Okay, so it's not just a component of greenhouse. It's a killer. It's a murder. Okay, it will also. We just mentioned this. This guy will destroy ozone layer. This guy will destroy ozone layer. Okay. Meteorology is the study of a lower atmosphere. Okay, especially weather. Okay. Particularly of weather. Show times. Okay, and climatology is the studies of weathers over long time. Okay, so this is short term. And this is long term. Okay. So meteorology studies short-term weather, and criminology study the long-term tenements. Okay, you might know this. Nowadays, okay, in our atmosphere, we have like 78% nitrogen and 21% oxygen, and the rest of them occupy less than 1%. Okay, the rest of them occupy less than 1%. And argon is a third. Argon is a third, occupying 0.9%. Okay, so this is the current atmosphere, and this is so-called Pumurative, which means ancient, or the early atmosphere, the ancient atmosphere. 早期的 okay, early Earth. Okay, the atmospheres in the early Earth. Okay, so you can see totally different, right? So the main components of the atmospheres gases, atmospheric gases in early Earth, including like oxygen, but very trace, carbon dioxide, methane, and ammonia. Okay, and nowadays the oxygen occupies 21%. Okay, most of oxygen was generated by the ocean plants. Those cyanobacteria. Okay, cyanobacteria. The ancient plants, all cyanobacteria. The ocean bacteria. The bacteria in the ocean. The scientists suspect most of oxygen is from something called cyanobacteria. So it's a bacteria. It's not algae. 不是藻类. It's a bacteria. So it's called cyanobacteria. Its old name, 它以前的名字 its old name is called blue-green algae. Okay, its old name is called blue-green algae. 蓝绿藻. So lots of people think about they are algae. No, they are not algae. They are bacteria. Okay, because they have chlorophyll, not chloroplast. Chlorophyll is kind of pigment. They have chlorophyll in their body, so they can do photosynthesis. Okay, so the scientists suspect, scientists doubt, most of the oxygen nowadays was produced by cyanobacteria. Okay, so its old name is used to call blue-green algae, and because we call it blue-green algae. And lots of students think they are algae. No, they are not algae, and they are not plants. They are bacteria. They just have chlorophyll, 叶绿素, in their body. Okay, understand? next slide. Okay, next slide I want to talk about this. Okay, next slide I want to air movement in the lower atmosphere. Okay, okay. You might learn this in heat transfer, right? Or fluid mechanics, unit operation, transfer phenomena. So air move, okay, due to temperature difference. Due to temperature and pressure difference. So if this is a natural convection, because of temperature and pressure difference, it will generate something called buoyancy, 浮力, right? Generate buoyancy, okay, the buoyancy, and cause the airflow, cause the airflow. So hot air goes up, and cooler air comes down, right? You might notice in your unit operation course. Okay. So it generated by temperature gradients and all the pressure gradients. Okay, so temperature and force gradient generate this so-called buoyancy in positive flow. Okay, so let's see this large scale movement. Okay, so if this is the lower pressure regions, so we know that air will move toward the lower pressure region and rise upward, right? So, for example, like the clouds, stones, right? And for high pressure regions, okay, for high pressure regions, the air stinks. The air stinks downward. The air stinks downward. Okay, so it will make a clear sky. A clear sky. Okay, so let me make a note. So lower pressures. So convergent air. Converging airs flow to the lower pressure regions, right? And air will raise and produce something called cloud. For high pressures, for high pressures, divergent air sinks 沉下去 and make clear sky. Okay, very clear sky. So you might consider lower temperature close to bad weather. Okay, gonna keep continuing to do that. And higher temperatures means good weather. Understand? So you might regard lower temperatures. That means bad weather is coming. Higher pressures, that means good weather. Good weather. Understand? Student, everyone? Okay? Okay, let me finish the stability. I will let all of you go. Okay, stability is a tendency of atmosphere to resist motion. Okay, it's difficult to understand this. Okay, let me make this easier. This means how much the air resists vertical motion. This means how much the air resists vertical motions. So stable air means it resists rising or even sinking. Okay, stable air means it resists sinking or rising. Okay, and unstable air means it encourages or stimulate. It encourages vertical, just in opposite, vertical motion. Okay? So unstable air encourages vertical motion. And stable air, so-called neutral, it resists rising and sinking. And the last thing I mentioned, okay, so let's start from here, is lapse rate. So lapse rate, the formula for lapse rate is delta T over delta Z. So that means how temperature changes with height. Okay? Everyone? Okay? Okay, next week, 帮我记一下，下礼拜从这边开始。Okay. Next week, I'm gonna start from here. Okay. So after air pollution, I'm gonna move on to. So after air pollution, I'm gonna move on to. Let me see. We're going to move on to the noise pollutions. Oh, sorry. I will do the silent management first. Okay? I will do the silent management first. I think it's fine. I think I will do noise pollution. Okay. I will do noise pollution. Okay, let's take attendance. Zivanya, Avina, 这个来了 Brilliant, Axel, Aki, Renner, Iza。刚才有一个请假的，忘了叫什么名字，
都叫那个
玉祥、俊志、泰正有来吗？陈阳、Stone 哥、彦勋、邵，我记起来了，林家伟，然后去看医生，然后前面两个。邵琪、秉纯、孟轩、林月、秉杰。Okay, so next week, Professor Wei Hong Jiang. Okay, I don't know if you guys know about him. Okay, he's very handsome. Okay, the most handsome. Oh, the second handsome, most handsome. The most handsome professor in our department. Professor Wei Hong Jiang will come over now. Okay, that's for today. Thank you so much for coming.